this banker's algorithm, it is used to avoid the deadlock. Means before it occurrence only, it will try to allocate the resources to the process in such a way that your system it will always remain in the safe state, and because of this deadlock it will never occur. So now why this name is given to this algorithm, means why it is called as banker's algorithm. So this algorithm, it is named as banker's algorithm because it is used in the banking system. Now, why it is used in the banking system? So it is used in the banking system to check whether loan can be sanctioned to a person or not. So when the loan is sanctioned to a particular person, then how that loan is sanctioned? That is depending on which condition your bank is sanctioned loan to the customer. So suppose there are n number of account holders in your bank, and the total deposit in a bank is, let us consider it as capital D. That is total amount of money available in the bank. It is equal to capital D, and n number of account holders are there in your bank. And let us consider that if a person applies for a loan. So when the person applies for the loan, then how your bank it will check the means how your bank it will check whether to issue the loan to the customer or not. So in that case, what your bank will do, your bank first subtracts the loan amount which is required by the customer. So it first subtracts the loan amount from the total money which is available in your bank. So if the total amount of total money which is available in your bank, if it is greater than or equal to the loan which is required by the customer, then only your bank it issues loan to that customer. Means then only the loan is sanctioned. And if it is and it is done because why bank is performing this task? Because let us consider that if all the account holders come into the bank to withdraw their money, then bank can easily do that, or bank can easily give their money to the respective customer, because that money it is always available in the bank after giving a loan to the customer. So in other words, the bank would never allocate its money in such a way that it can no longer satisfy the needs of the available customers, and the bank it would try to be in safe state always. So this mechanism it is used by the banker's algorithm to avoid the deadlock. Okay, so this banker's algorithm it is the resource. This algorithm is called as resource allocation algorithm, and along with that it is also called as deadlock avoidance algorithm. So now how this banker's algorithm it works? So initially this banker's algorithm it tests all the requests made by the processes for resources. Means initially in the multi-processing environment, a number of processes are there, and number of processes it required number of resources to complete its execution. So here at first your banker's algorithm it will check that how many number of processes are currently available in your system. After that, it will check that how many number of resources required by all the processes to complete its job. And after that, by using this number of processes and number of resources, your operating system it will check that after allocating the resources to the process, whether your system it will enter into the safe state or into the unsafe state. So if after granting the request, if your system it will entered into the safe state, then it allows the request to the process. That is, if your system will entered into the safe state, then only it will allocate the resources to the process. And if your system it enters into the unsafe state, that is, if deadlock will occur, then your operating system it doesn't allow the request made by the process. That is, it will not allocate the resources which are required by the process to complete its job. So what is the main condition here? If your system is in the safe state, then only your operating system allow or allocate the resources to the process. And if it is in the unsafe state, then it will never allocate the resources to the process. Okay. So this is your banker's algorithm. So now for executing the banker's algorithm, what are the necessary inputs which are required for the banker's algorithm? So you have to feed data to the banker's algorithm, depending on which your banker's algorithm, it will decide whether it is the safe state or unsafe state. So the first input which is required by the banker's algorithm is the maximum number of resources which are required by different processes to complete its job. What is the meaning of this? Let us consider, suppose three processes are there. The process P1, it requires 10 printers to complete its job. Then process P2, it requires 10 memory to complete its job. And process P3, it requires 10 CPU cycle to complete its job. So what these three processes will do? So these three processes, it will inform the operating system is before starting its execution only, these three processes will inform the banker's algorithm that I need maximum 10 printers to complete my job. Then P2, it will inform that I need maximum 10 memory. P3, it will inform that I need maximum 10 CPU cycles to complete my job. So this information, it is already given to the banker's algorithm. Then only banker's algorithm, it can decide whether the system, it enters into the safe state or unsafe state. So this is the first input which is given to the banker's algorithm. After that, the next input is that here it will means this process, it will also provide the information that how many resources are currently allocated to the process. Now, what is the meaning of this? If they are initially informing the operating system or banker's algorithm that they require 10 resources or 15 resources to complete its job, then how the resources are allocated to the process? So here let us consider that in the multi-programming environment, initially only one process is there in the ready queue. Only one process is arrived in the ready queue. Let us consider that at 1 o'clock, only one process is arrived. And that process one, it require 10 printers to execute its job. So as only one process is available in the ready queue, so your operating system, it will allocate, let us consider that your operating system, it will allocate 5 printers. Though 10 printers are available in the system, your operating system, it will not allocate all the 10 printers to the process 1, because it will think that afterwards other process will enter into the ready queue. So that is why, to avoid the deadlock, it will not assign all the printers to the process 1, though only one process is available in the ready queue. So let us consider that it will allocate only 5 printers to the process 1. Then after that, process 2 enters into the ready queue, and after that it will request that I required 10 CPU cycles to complete my job. But your operating system, it will allocate suppose only 3 CPU cycles to execute its job. So like this. So now in the multiprocessing environment, suppose now 20 processes are there which are entered into the ready queue. So that time, here every process, as number of processes have arrived in the ready queue, so all the processes will inform the operating system that how many resources are required by that process to complete its job. But initially process P1 and P2, it entered into the run state, and that time they are already holding some resources with them. So now when we are running the banker's algorithm to avoid the deadlock, so in that case process P1 and P2, they will inform the banker's algorithm that currently we are holding 5 printers or 5 CPU cycles with us, and we require more printer and more CPU cycle to complete my job. So along with the maximum number of resources required to complete the job of the process, it will also inform the banker's algorithm that how many resources are currently allocated to that process. Then in the third input which is given to the banker's algorithm is that how many number of free available resources are there in the system. That is, initially I told you the example of process P1 and P2. So suppose in your system 10 printers are there and 10 CPU cycles are there. That is 10 CPU are there, because here we are considering multi-user, multitasking, time sharing environment. Here number of CPU or servers are there that are shared by number of users. So suppose that 10 servers are there, and now that 10 servers that are shared by multiple users. So initially when process P1 and P2 entered into the system, so as only two processes are in the ready queue, your operating system, it has allocated 5 printers and 5 CPU cycles to process P1 and P2. So after allocating the 5 printer and 5 CPU to the process P1 and P2, the number of free available resources with the operating system are 5 printers and 5 CPU cycles, because total number of resources available in the operating system are 10 printers and 10 CPU cycles, from which the 5 printer and 5 CPU cycles that are already allocated to process P1 and P2. So here, while providing input to the banker's algorithm along with the currently allocated resources, we're providing the maximum number of free available resources to the in the system. That input is also given to the banker's algorithm. Okay, so and your banker's algorithm, it will allocate the resources to the process only when your system, it will satisfy the following condition. So what is that condition? That is, if the request made by the process is less than or equal to the number of freely available resource, its meaning is that your system is present in the set state, and then only your operating system, it will allocate the resource to the process. What is the meaning of this? Suppose P1 and P2 already running in the run state, and suppose process P3, it has arrived in the ready queue. And suppose process P3, it required 6 printer to complete its job and 7 CPU cycles, or let us consider that it requires 6 printer and 2 CPU to execute its job. So currently the number of available free resources in your operating system are 5 printers and 5 CPU. But your process P3, it required 6 printer and 2 CPU. So one of the condition is satisfied, but one of the condition is not satisfied by the operating system, because your third process, it required 6 printer. That is 1 printer greater than the number of available resources. So in that case, though the CPU is available with the operating system, your operating system, it will not grant request to the process P3, because the number of available resources in the system are less than that the number of resources required by the process to complete its job. Suppose process P4 entered into the system, and that process P4, it require 1 printer and 1 CPU to execute its job. So number of required resources that are less than or equal to the number of free resources available in the operating system, because number of free resources available in the operating system are 5, but your process P4, it required 1 printer and 1 CPU. So in that case, your operating system or banker's algorithm, it will allocate the resources to the process P4, and process P4, it will enter into the run state. And process P3, it can enter into the run state only when the 6 printer and 2 CPU cycles are available to that process. So in every step, your banker's algorithm, it will check that after assigning the resources, whether your system is present in the safety state, or whether it is present in the unsafe state. So if unsafe condition is there, if deadlock will occur, then your system, it will never allocate the resources to the given process. So now see, so here we will solve the problem for this. So let us consider that now all of you know that to execute the job for the process, it requires different types of resources. So here we will consider the input device, output device, and CPU. So let us consider that in your system 10 printers are there. We will consider it as a variable A. 5 scanners are there. So this is the input device. We will consider it as variable B, and 7 CPUs are there, that is central processing unit. So these are the total number of resources available in your system, and we are using the multi-processing environment, that is number of processes are currently running in your system. So let us consider now how the problem can be asked in the exam. So in the exam, the tabular representation is given, then number of processes are given, along with that the total number of available resources are given, total number of allocated resources are given, and along with that the maximum number of resources required to complete the job of the process, that is also given. And here you have to find out that after allocating the resources to the process, whether your system, it entered into the safe state or unsafe state. Okay, now see, so in this tabular representation, it is given that currently 5 processes are there which are present in your system, that is P1, P2, P3, P4, and P5. And here A, B, and C, where A is representing printer, B is representing scanner, and C is representing CPU. So initially P1 is entered into the ready queue, and after that it will ask the operating system that to complete my job, I required 7 printers. See, this is maximum need which is required by the process to execute or to complete its job. So this P1, it tells the operating system that I required 7 printer, 5 scanner, and 3 CPU to complete my job. But initially, to avoid the deadlock or to maintain the safe state, though the number of total resources available, free resources are available with the operating system, but here operating system, it will consider that I am working in the multi-processing environment. So after process P1, other process can enter into the ready queue and they can ask for the resources. So that's why initially your operating system or your banker's algorithm, it will assign 0 printer and 0 CPU. That is, none of the printer and none of this CPU is assigned by the operating system to the process P1. And initially, it will assign only one scanner to the process P1, though it requires 7, 5, and 3 resources respectively. After that, let us consider that process P2, it is arrived in the ready queue. And process P2, it requires 3 printer, 2 scanners, and 2 CPU to complete its job. But again, considering the multiprocessing environment, your operating system, it will allocate only 2 printer to the process P2. And here it will not assign any scanner and CPU to the process P2. Same with the process P3. P3, it required 9, 0, and 2 resources respectively, but your operating system, it will allocate only 3 printers and 2 CPUs to the process P3. Then process P4, it required 4, 2, and 2 resources respectively to complete its job, but your operating system or banker's algorithm, it will allocate only 2 printers, 1 scanner, and 1 CPU to process P4. Same for the process P5. It required 5, 3, and 3 resources to complete its job, but banker's algorithm or operating system, it will allocate only 2 CPUs to the process P5. Okay, so this scenario is given in the exam, and by using this scenario, you have to find out whether your system will enter into the safe state or it will be entered into the unsafe state. And here, by using this scenario, you have to try to avoid the deadlock. Means you have to try to maintain the safe condition so that your system, it will never entered into the deadlock, and all the process will able to execute their job successfully. Now see, number of allocated resources are given, the number of resources, maximum resources which are required by the process to complete its job is given, total number of resources available in the system are also given. Now how to find out this safe condition here? Means here you have to try to execute all the processes without the deadlock. So how to do this? So at first, what I will do here, at first we have to find out the total number of resources allocated to all the processes. These are the total available resources, but उसमें से कुछ number of resources है which are already allocated to the process. How many number of printers, how many number of scanners, and how many number of CPUs are assigned to all the processes. 7 printer, 3 plus 2, 5 plus 2. Yes, 7, kitna? 2 scanner, and how many number of scanner, how many number of CPU? CPU kitne ho gaye? 5. Yes. So see, what you have to do, you have to add the total number of resources allocated to the process. So here I will add all the numbers from this column. So 7 printers are assigned to all the processes, 2 scanners are assigned, and 5 CPUs are assigned for all the processes to complete its job. Okay. Now after that, now here this is the maximum need of all the processes. These columns are representing the maximum need, and this is representing the allocated resources. Now here, from this maximum need and allocated resources, we can find out the number of remaining resources which are required by the process to complete its job. So here we will subtract the number of allocated resources from the maximum need of the process. Because now here you can see that the number of printers required by the process P1 are equal to 7. But operating system, it has assigned only 0 printer. That is, none of the printer is assigned to it. मतलब this process P1 it required 7 minus 0, that is 7 printers to complete its job. Now it required 5 scanner to complete its job, but your operating system it has allocated only one scanner to the process P1. So number of remaining resources which are required by the process P1 to complete its job are 5 minus 1, that is 4. Then it required 3 CPU, but operating system it has assigned only 0 CPU. So what we will do here? 3 minus 0, that is 3. Okay. So like this you have to do. So what will be the formula here? Maximum need of the process minus the total number of allocated resources. So maximum need यहाँ पे दी है, means you have to subtract this column from this one. Okay. So it is 743. Other students need 743. ओके फॉर P2 के लिए 122. ओके फॉर P3, so P3 is 600. P4, so it is 211. Then P5, so it is 531. So like this we can find out the remaining need of the process to complete its job. Okay. So now here from this formula here we have calculated that how many number of resources are required for the process to complete its job. Now what we will do here? Now here we have already obtained the total allocated resources for each total number of allocated resources for all the processes. And here we were having this data with us that how many number of total resources available in the system, that is 10, 5 and 7. So what we will do now, we will calculate the number of freely available resources in the system. So total number of resources आपको पता है, total allocated resources we know. So how we will find out? We will subtract this total allocated resources from the total number of resources 3 and 2. Understood that how to find out the available resources? 10 minus 7, that is 3. 5 minus 2, that is 3. And 7 minus 5, that is 2. Okay. Yes, other students, have you understood this? That how we are calculating the number of available resources? Okay. So here write down now. See, यहाँ पे मैंने क्या लिखा है अभी? Number of available resources, that is 3, 3 and 2. ठीक है. अभी हमारे पास ऑपरेटिंग सिस्टम ने ऑलरेडी कुछ रिसोर्सेज अलोकेट किए सब प्रोसेस को, एंड दीज आर द नंबर ऑफ अवेलेबल रिसोर्सेज. Now by using these available resources, now we will execute all these processes and we will try to enter into the substate and we will try to execute all these processes. तो अभी कैसे करना है? तो यहाँ पे we will start from the process P1. Here we will follow the sequential manner. Okay, we will execute all the processes in sequentially. तो ये आपके available resources हैं. And here process P1 it required 7 printer, 4 scanner and 3 CPU to complete its job. But हमारे पास number of available resources that are less than that of the required resources by the process P1, क्योंकि यहाँ पे हमारे available resources कम है और process P1 को तो ज्यादा resources लगने वाले हैं execute करने के लिए. So what your banker's algorithm will do? It will not assign the resources to the process P1. It will check the other process which is present in your system. So the next process which is available in your system is process P2. तो यहाँ पे it will check that how many resources are required by the process P2 to complete its job. तो प्रोसेस P2 को कितने प्रिंटर लगने वाले हैं? 1. हमारे पास कितने प्रिंटर है? 3. प्रोसेस P2 को 2 स्कैनर चाहिए, हम लोगों के पास 3 स्कैनर है. इसको 2 CPU चाहिए और हमारे पास 2 CPU है. मतलब नंबर ऑफ अवेलेबल रिसोर्सेज दैट आर लेस देन और ग्रेटर देन और इक्वल टू द नंबर ऑफ रिसोर्सेज रिक्वायर्ड बाय द प्रोसेस P2 टू कंप्लीट इट्स जॉब. मतलब जो अवेलेबल रिसोर्सेस है उसमें हमारी प्रोसेस P2 कंप्लीट हो सकती है. So what your banker's algorithm will do? Banker's algorithm it will assign these 1 printer, 2 scanner and 2 CPU to the process P2. तो यहाँ पे तुम्हारी आपकी प्रोसेस P2 इसमें से अपने नंबर ऑफ अवेलेबल रिसोर्सेस दैट इट विल टेक, नंबर ऑफ रिक्वायर्ड रिसोर्सेस इट विल टेक एंड इट विल कंप्लीट इट्स जॉब. तो अभी प्रोसेस P2 ने क्या कर लिया है? यहाँ पे 1 प्रिंटर, 2 स्कैनर एंड 2 CPU ले लिए, उसने अपना जॉब कंप्लीट कर लिया. So after that your process P2 it will entered into the terminate state because ये number of available resources में से उसका काम हो गया. So process P2 it is terminated, it will entered from run state into the terminate state. तो process P2 का तो काम हो गया. अभी प्रोसेस P2 ने ऑलरेडी, ऑपरेटिंग सिस्टम ने ऑलरेडी प्रोसेस P2 ने जब एंटर किया था रेडी क्यू में, एंड व्हेन इट वाज इट हैड रिक्वेस्टेड फॉर द रिसोर्सेज, दैट टाइम योर ऑपरेटिंग सिस्टम इट हैड allocated टू प्रिंटर्स टू द प्रोसेस P2. तो प्रोसेस P2 ने ऑलरेडी पहले से ही दो प्रिंटर अपने पास रखे थे. बट नाउ व्हाट योर बैंकर्स एल्गोरिदम विल डू, कि प्रोसेस P2 ने तो अपना जॉब कर लिया नंबर ऑफ अवेलेबल रिसोर्स में से. अभी ये प्रोसेस ने वो प्रोसेस इज एंटर्ड इनटू द टर्मिनेट स्टेट. तो अभी ऑपरेटिंग सिस्टम विल डू व्हाट इट विल डू, इट विल release, means your process P2 it will release the resources which are already allocated to it. जो दो प्रिंटर्स हमने प्रोसेस P2 को अलोकेट किए थे वो रिलीज करेगी, मींस इट विल लीव दैट रिसोर्सेज. सो दिस नंबर ऑफ प्रिंटर्स, टू प्रिंटर्स, इट विल गेट एडेड इनटू द नंबर ऑफ अवेलेबल रिसोर्सेज. मतलब इसमें ये नंबर ऑफ रिसोर्सेज रिलीज करने के बाद ये नंबर ऑफ अवेलेबल रिसोर्सेज में ऐड हो जाएगी. मतलब यहाँ पे थ्री प्रिंटर थे, प्रोसेस P2 ने अपने पास जो प्रिंटर थे वो दे दिए, मतलब 3 + 2 5. लेकिन प्रोसेस P2 ने स्कैनर और सीपीयू कुछ भी ऑपरेटिंग सिस्टम ने उसको असाइन नहीं किया था. सो दिस नंबर ऑफ अवेलेबल रिसोर्सेज, दैट इज 3 स्कैनर एंड 2 सीपीयू, दैट विल रिमेन एज इट इज. सो इट विल बी लाइक दिस. ओके, प्रोसेस P2 ने अपना जॉब कंप्लीट कर लिया तो वो टर्मिनेट स्टेट में आ जाएगी यहाँ पे. एंड हियर it will release the resources, and here you will get the number of available resources that are equal to 5, 3 and 2. मतलब ये 2 + 3 5 हो गया आपका, और 0 + 3 3 and 0 + 2 2 हो गया. So now these are the available resources which are present in the system. Process P2 ने तो अपना काम कर लिया, and here we are following the sequential approach. So now what your bankers algorithm will do, it will check whether the next process which is available in the ready queue, whether it is able to complete its job. लेकिन अभी ये जो नेक्स्ट प्रोसेस है P3, उसको तो 6 प्रिंटर्स चाहिए अपना जॉब कंप्लीट करने के लिए, लेकिन हमारे पास तो सिर्फ 5 प्रिंटर अवेलेबल है. मतलब ऑपरेटिंग सिस्टम इसको रिसोर्सेस नहीं अलोकेट कर सकती है. सो इट विल लीव दैट प्रोसेस, देन इट विल चेक द नेक्स्ट प्रोसेस व्हिच इज अवेलेबल इन द क्यू. तो नेक्स्ट प्रोसेस कौन सा है आपका P4. P4 को दो प्रिंटर चाहिए, वन स्कैनर चाहिए एंड वन सीपीयू चाहिए. तो यहाँ पे द नंबर ऑफ रिक्वायर्ड रिसोर्सेज दैट आर लेस देन और इक्वल टू नंबर ऑफ अवेलेबल रिसोर्सेज. इसका मतलब है जो अवेलेबल रिसोर्सेज है उसमें से ये प्रोसेस P4 अपने रिसोर्सेज ले सकती है. सो ऑपरेटिंग सिस्टम इट विल allocate the resources to the process P4. P4 it will complete its job, and after that, after completing its job, your process P4 it will entered into the terminate state. तो यहाँ पे P4 ने अपना काम कर लिया, लेकिन प्रोसेस P2 जब टर्मिनेट स्टेट में जाएगी तब प्रोसेस P4 क्या करेगी यहाँ पे, कि इट विल रिलीज ऑल द रिसोर्सेज विच आर अलोकेटेड टू इट सो दैट अदर प्रोसेस कैन यूज इट. तो अभी ऑलरेडी अलोकेटेड रिसोर्सेज P4 को कौन से थे, टू प्रिंटर थे, वन स्कैनर था और वन सीपीयू था. तो यहाँ पे अभी क्या होगा कि वो प्रोसेस रिलीज करेगी. तो नंबर ऑफ अवेलेबल रिसोर्सेस हमारे प्रिंटर कितने हैं, 5. अभी प्रोसेस P4 ने देने के बाद कितने, 4 एंड इट इज 3. यस, तो प्रोसेस P5 एग्जीक्यूट होने के बाद क्या होगा, यहाँ पे P5 हम लोगों को कट करना है, वो टर्मिनेट स्टेट में डालना है, 7 4 and 5. यस, yes, very good. So it is 7 4 5. Now tell me, now here we are following the sequential manner. So again it will go to the first process. So tell me what P1. तो अभी प्रोसेस P1 टर्मिनेट हो जाएगा एंड इट विल एंटर्ड इनटू द टर्मिनेट स्टेट. और उसके बाद मुझे, तो प्रोसेस P1 टर्मिनेट होने के बाद यू विल गेट 7 5 5. यस, कंप्लीट हो जाएगी क्योंकि नंबर ऑफ अवेलेबल रिसोर्सेज 755 है और उसको 600 ही रिसोर्सेज लगने वाले हैं. तो प्रोसेस P3 आपका कंप्लीट हो जाएगा, इट विल एंटर्ड इनटू द टर्मिनेट स्टेट एंड टेल मी दी 5 and 7. ओके, so how to check whether the system is in the safe state or not, कैसे चेक होगा आपका. So here you can check that number of total resources available in the system are 10 5 7. एंड अभी सब प्रोसेस एग्जीक्यूट होने के बाद हमारे पास कितने प्रिंटर्स है, 10 प्रिंटर्स, 5 स्कैनर एंड 7 सीपीयू. तो ये नंबर ऑफ अवेलेबल रिसोर्सेज दैट आर इक्वल टू टोटल नंबर ऑफ रिसोर्सेज अवेलेबल इन द सिस्टम. तो यहाँ पे ये वैल्यूज मैच हो गई, इसका मतलब है कि हमारी सिस्टम सेफ स्टेट में है एंड हियर वी कैन स्टॉप.